So continuing with our exploration of impossible gears, that is, gears that can get a gear reduction even though they're the same size, we've done a fair bit with bevel gears using that rotation. Now the original one we did was this one, which was with spur gears, and we used this lever arm to actually get that effect. Of course the next question is, can we get rid of that lever arm, and can we use just spur gears to achieve this reduction in the same way that we just used bevel gears? Now, if we use a structure like this, where we've actually got a rotating cage that goes around that gear, then the answer is absolutely yes. And we need to print that off and assemble it so that we can check that it will in fact do that job. So here are the parts printed off. And the first job is to take the bottom of the cage, which is this bit with the sticky up axles, and take this bit and glue it so that that goes in there and it protrudes 1 millimeter. Now that bit is going to be the bit that we drive. Then we need to take this. This will in effect be a fixed gear. To have that gear fixed, we need to put an axle in it there, and we'll fix the axle and fix the gear to the axle, which will in effect make that a fixed gear. So we need to push the axle through that. But the axle also needs to go all the way down there, plus an extra 6 millimeters. Now all I did to do that was pop it on there and drive it all the way through, and then this will be 6 millimeters deep, so on there and drive it to the bottom, and you'll have that in the correct position. That then slots in here. Then we have our idle gear. The first idle gear goes on that way. The second idle gear, you turn the other way around and it goes on that way like that. And then we have our output gear, which is this one here, and that slides on there and engages with the second idle gear like that. Then what we do is that way around, pop the top on the cage. Okay, remember this one is fixed, so if we hold that, and that's driving the cage, and drive the cage, it goes nicely round with that effectively a fixed gear. In order to do that, we need some supports, so that support goes on here, and then we have a drive gear, which is this slightly larger drive gear, and that goes on there like that. Then this support goes on here, which is nice and loose, and we have an output gear which goes on there like that. So we assemble those, we can drive this, and it will to output on this. That whole assembly then goes on the base on these inner two lines, right there. Now we need to fix that axle, which effectively fixes that gear, and for that we use these supports which go on there and there, and they'll be a tough press fit, but you might want to put a bit of glue on them to hold them in place. Right, I've put a dot on there and a dot on there, and that's our input gear. So as we turn that, where is it? There you go, that dot turns much faster. So let me give that half a turn. And you will notice that that dot has done one full turn, and by the time we get that back, then the dot is back into its place. So this turns once, that turns twice, and of course it is back drivable. So if I turn that, you can see how much slower that one is going, and it's going in a ratio of 2 to 1. So this may be a question of, little thoughts, little minds, little pants, little behinds, but I'm finding this absolutely fascinating that we can use gears of the same size to have this effect in a myriad of arrangements. And here we're just using spur gears, but of course we have introduced that idea of counter rotation, which is what this cage actually does. Anyway, Impossible Gears number 4. If you're finding this exercise fascinating, of course, like all of the others, this one I will put on Thingiverse should anybody want to explore it, or anybody finds it interesting and wants to do something about it, or maybe just have a good desk toy. I hope you enjoyed the video series so far. Thank you very much for watching, and please do remember to like and subscribe.